Welcome back everyone, Patrick here, and moving on to another question dealing with sets. So we got to find the union and intersection of these sets here. So there's two questions, and notice that each of the questions, they actually have three sets, A, B, and C. So what we're going to be finding is the union between all of them. So that would be A, U, B, U, C. And then the intersection between all of them. So that would be this over here. So I'm going to start with question one. We got x is an element of real numbers for set A such that 3x minus 2 is greater than 0. Set B is x is an element of real numbers such that x squared minus 3x is less than 4. And then set C is x is an element of real numbers such that 4 is less than 2x. So what I'm going to do is I'm going to take these sets and I'm actually going to put them in interval notation if possible, because we're dealing with real numbers here. So x is an element of real numbers here for set A, but it has to satisfy that inequality. Basically, 3x minus 2 has to be greater than 0. Well, if we isolate for the x, bring the negative 2 over, divide both sides by 3, that means x has to be greater than 2 over 3, like that. Okay, so set A, what we can do is we can rewrite it as 2 over 3 to positive infinity, not inclusive of 2 over 3. There's a circle bracket there. Set B is going to be the toughest to work with out of both. So x is an element of real number such that x squared minus 3x is less than 4. So what I'm going to do, I'm going to bring the 4 over. When is x squared minus 3x minus 4 less than 0? Notice this is a quadratic and it actually factors into x minus 4x plus 1. When's that going to be less than 0? Well, if we graph it, notice we have negative 1 as an intercept. We got positive 4 as an intercept. This is not to scale. And notice that this is a quadratic that opens up because we have positive 1 as the leading coefficient. If the leading coefficient is positive, it's a quadratic that opens up. So we'll have this right there. All right, this is negative 1, and then this is positive 4. So notice, when is it less than 0? In this area here, between negative 1 and 4, not inclusive of them, right? Because it's got to be negative, it's got to be less than 0, not less than or equal to 0. So set B, we can rewrite negative 1 to positive 4, like that. And then over here, set C, x is an element of real numbers such that 4 is less than 2x. Well, at this point, we just have to divide both sides by 2. X would be greater than 2. So set C would be from 2 to positive infinity, like that. Right? So now what I'm going to do is I'm actually going to put all these on a number line. So let's do that. Let's do it over here, actually. So this would be negative. Actually, we don't even need negative infinity. They're all going to positive infinity. So let's say, what's the lowest number? Okay, we got negative 1. We got 2 over 3. We got 2. And then we got 4, and then this is going towards positive infinity like that. So starting with set A, 2 over 3 to positive infinity. So it's going to be over here. Or no, sorry, it's an open dot. Like that, right? Set A, that's how you represent it on a number line. Set B is going to be from negative 1 to 4, not inclusive of those, so that's going to be here. And then set C is going to be from 2 to positive infinity, like that. So let's start with the intersection between them. Where are all three intersecting? What are the common values? Well, notice it's going to be this area over here, right? Where all three lines hit these values here. And it's basically between 2 and 4, because notice here, the 2 is not inclusive in this set. If this was a closed dot, then it would this intersection would include the 2, but it doesn't include the 2 for one of the sets, and over here we're not including the 4 for one of the sets. So the intersection would be from 2 to 4, like that. But for example, if this was a closed dot, well, then all the sets would have 4, and then this would be a square bracket right there. It would be inclusive of the 4, right? But that over here, that's a hole there. And then what's the union between them? So what are the elements in A or B or C? Well, notice it's pretty much going to be all the real numbers from -1 to positive infinity, right? Because no matter if we start at -1, it's not inclusive of -1, but if we keep going, it's not in this set. The 2 over 3 is not in this set or in this set, but it is in this set, right? The 2 is not in this set, but it is in this one and in this one. It's not, 4 is not in this one, but it's in this one and this one, and then these two go to positive infinity. So it's going to be from -1 to positive infinity, like that. That's what the union is going to be between the 3 sets. Right, so that's usually my process. I try to take the sets, try to simplify them as much as possible, throw them on a number line so I could kind of visually see it, and then from there I usually start with the intersection. I feel like it's a little bit easier usually to get than the union, because you just have to look for when are all 3 sets going to be covered, in what range. And yeah, that is my process for working with 3 sets. And then finally, number 2, we got set A, x is an element of integers such that x squared is less than 5. Then we got x is an element of natural numbers for set B such that x is less than 5. And then for set C, we got x over 2 such that x is an element of natural numbers and x is less than 5. So these sets are actually really different than these because these here, they're actually finite sets when we're going to work with them. So we can actually list out all of the numbers in, I'm going to list them out in roster notation, versus these ones, they were infinite sets. So starting with set A, x is an element of integers such that x squared is less than 5. Well, if we take x squared, if we graph it, when is it going to be less than 5? Well, notice that the intercepts here would be, the x values at these points would be √5, -√5, and positive √5, right? When is x squared equal to 5? When x is plus or minus √5. So what are the integers between -√5 and positive √5? Sorry, I put 5 there. Between -5 and positive √5, the integers are going to be -2, -1, 0, 1, and 2. So this set we can rewrite as -2, -1, 0, 1, and 2, like that. If you take all these integers, like -2 squared, notice it's less than 5. -1 squared is positive 1, less than 5. 0 squared is 0, which is less than 5. 1 squared, 2 squared, they're all less than 5. But notice that if we took 3, the next integers, to both sides, 3 and -3, notice that both of those squared would be 9, which wouldn't be less than 5. It wouldn't meet that condition right there. Right, so set A we can rewrite like this. What about set B? Set B is pretty easy. X is an element of natural numbers. All the natural numbers, which is what? All the positive integers starting at 1, 1, 2, 3, 4, 5, etc., etc. All the natural numbers that are less than 5, well, that's just going to be 1, 2, 3, and then 4, like that. And then set C, we have a formula, x over 2 for the elements, such that x is an element of natural numbers and then x is less than 5. So all the natural numbers that are less than 5, what were they? They were 1, 2, 3, 4, but now we got to take these and plug them into this formula. So we would have 1 over 2, 2 over 2, which is 1, 3 over 2, which is 1.5, and then 4 over 2, which is 2, like that. So took these sets, rewrote them like this. And now this here is just way easier to work with. So what's going to be the intersection? What's common? What elements are common in all the sets? Well, if we look closely, it's the 1 and the 2. Right? Notice these fractions, they're not in either of these sets. Notice that, yeah, they don't have, these don't even have any common elements except the 1 and 2. Over here, actually, oh no, yeah, so 1 and 2 are the only elements that are common in all the sets. And even still, let's say like this set, set A, had an element 4. So even though it's a common element in both of these, it's not in C, so it wouldn't be in the intersection of all 3. Now, it would be in the intersection of A and B, but it wouldn't be in the intersection of all 3, like that. Right? So this set here is 1 and 2. That is the intersection set of these 3 sets. And then what's the union? It's got to be an A, B, or C. Well, it's pretty much going to be, notice this is in order -2, -1, 0, 1, 2. 1, 2, we already covered that. 3 and 4, 1 and 2, we covered that. And then we have the fractions here. So I'll write out the integers first. You don't have to put them in any specific order. But you know what? Let's put them in a nice order here. 3 over 2 is 1.5. I was going to put the fractions at the end, but that's fine. 2, 3, 4, like that. -2, -1, 0, 1, 2, 3, 4. And then we got the 2 fractions, right? So it's basically all of the elements in all the sets, but any elements that appear multiple times, so like the 1 and 2, you only write once, right? You never write an element twice when you're dealing with sets, all right? So for question 2, that's the intersection right there, and then that's the union set.